In this video, we are going to discuss De Moivre's theorem, PYQ, many times repeated in the examination. The question is, if cos alpha plus cos beta plus cos gamma is equal to 0, and also sin alpha plus sin beta plus sin gamma is equal to 0, then prove that cos square alpha plus cos square beta plus cos square gamma is equal to 3 by 2, and also sin square alpha plus sin square beta plus sin square gamma is equal to 3 by 2. Now here in the solution, so given that cos alpha plus cos beta, cos alpha plus cos beta plus cos gamma is equal to 0, and also sin alpha plus sin beta plus sin gamma is also equal to 0. So now let consider, let x is equal to prove the required thing. Here x is equal to, so take a complex number, cos alpha plus I sin alpha, So y is equal to cos beta plus I sin beta, y is equal to cos beta plus I sin beta. Z is equal to cos gamma plus I sin gamma, if you consider. Now adding therefore x plus y plus z, so which is equal to, so cos alpha plus I sin alpha plus cos beta plus I sin beta, plus I sin beta, and plus cos gamma plus I sin gamma, So then here separate the real part and imaginary parts here. So here cos alpha plus cos beta plus cos gamma, this is the real part, and imaginary part is here I into, so this is sin alpha plus sin beta, so plus sin gamma. See what happened here, already we know that cos alpha plus cos beta plus cos gamma is equal to 0, and sin alpha plus sin beta plus sin gamma is equal to 0. So now which becomes, this is 0 plus I into 0. So finally we are getting 0. So therefore x plus y plus z is equal to 0 we get. So x plus y plus z is equal to 0. So then squaring on both sides, we get here, so x plus y plus z whole square, x plus y plus z whole square is equal to 0 square. So we know that this is like a plus b plus c whole square. So what is a plus b plus c whole square formula here? So a plus b plus c whole square, so which is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So we know this is the formula. Similarly, in terms of x plus y plus z whole square, also we get x square plus y square plus z square plus 2 into xy plus 2 into yz plus 2 into zx is equal to 0. So further it becomes, so which implies x square plus y square plus z square is equal to, send these terms to the right side. So we have minus 2, if you take, this is minus 2xy minus 2y minus 2zx. If you take the minus 2 common here, so xy plus yz plus zx only we get. So further it can be written as, so if you take here, in all the three terms, suppose x, y, z common, so we can write here 1 by z plus here 1 by x plus here 1 by y, so which becomes therefore x square plus y square plus z square, so which is equal to minus 2xyz into, we can write 1 by x plus 1 by y, so plus 1 by z. So now keep aside, this is x square plus y square plus z square is equal to minus 2xyz into 1 by x plus 1 by y plus 1 by z. So now consider already we have x is equal to cos alpha plus I sin alpha. So x is equal 1 by x is equal to, so we have 1 by cos alpha plus I sin alpha. 1 by cos alpha plus I sin alpha. So rationalizing with, so cos alpha minus I sin alpha. That means multiplying numerator and denominator by cos alpha minus I sin alpha. So what we get here, cos alpha minus I sin alpha. So which is equal to 1 by x is equal to, so this is cos alpha minus I sin alpha whole divided by, which is, so like a plus b into a minus b, this is cos alpha whole square, and here so a square minus b square, that is minus I sin alpha whole square, so which becomes here, further we get cos alpha minus I sin alpha whole divided by, so which is cos square alpha and minus I square sin square alpha we get. So now 1 by x is equal to, so cos alpha minus I sin alpha whole divided by, so this is cos square alpha and minus I square values we know that minus 1, so that's why here, so replacing I square by minus 1, which is nothing but cos square alpha plus sin square alpha. So this implies 1 by x is equal to, we get cos square alpha plus sin square alpha is equal to 1. So cos alpha minus I sin alpha we get. So similarly we can prove that 1 by y, 1 by z. So already we have 1 by x is equal to, so cos alpha minus I sin alpha. Similarly we can prove that, so 1 by y is equal to cos beta minus I sin beta, and 1 by z is also is equal to cos gamma, so minus I sin gamma. So now again therefore 1 by x plus 1 by y, so plus 1 by z, which is also is equal to, so here cos alpha minus I sin alpha and plus cos beta minus I sin beta, so plus cos gamma minus I sin gamma. Now again separate the real parts and imaginary parts like before. So here cos alpha plus cos beta plus cos gamma, and here minus imaginary parts minus I if you take common from all the three, so minus I into sin alpha plus sin beta plus sin gamma we get. So sin alpha plus sin beta plus here sin gamma we get. So now here already we know that cos alpha plus cos beta plus cos gamma is 0. So this real part is 0, minus I into, so imaginary part is also is equal to 0. Finally we get this is 0. So therefore 1 by x plus 1 by y plus 1 by z is equal to 0. So we have here, so we have x square here, when you square the x plus y plus z whole square, so we get here x square plus y square, x plus y plus z whole square, x plus y plus z whole square is equal to, we have x square plus y square plus z square, so minus here minus 2 is equal plus 2xy plus 2yz, so plus 2zx actually. So when you take this is so here this is already 0, we get x plus y plus z is equal to 0. So from this we get, so x square plus y square plus z square is equal to, already we have minus 2xyz into 1 by x plus 1 by y plus 1 by z. Now we get 1 by x plus 1 by y plus 1 by z is also is equal to 0. So finally we get x square plus y square plus z square is equal to minus 2xyz minus 2xyz into 0. So finally we get, so x square plus y square plus x square plus y square plus z square, so which is equal to 0 we get. So now therefore what is x here? We have x is cos alpha plus I sin alpha whole square and plus cos beta plus I sin beta whole square plus cos gamma, so plus I sin gamma whole square, so which is equal to 0 only. See now here, if you apply the De Moivre's theorem here, so this becomes cos 2 alpha plus I sin 2 alpha and here plus cos 2 beta plus I sin 2 beta plus cos 2 gamma plus I sin 2 gamma, so which is equal to 0 only we get. Again separate the real parts here, cos 2 alpha, cos 2 beta, cos 2 gamma. So this is cos 2 alpha plus cos 2 beta plus cos 2 gamma, which is so, and I, if you take the common from these three, so the imaginary values are I into sin 2 alpha plus sin 2 beta plus sin 2 gamma, which is equal to 0. So if you compare the real parts, equating the real parts, suppose equating real parts on both sides, then we get here cos 2 alpha plus cos 2 beta plus cos 2 gamma, so which is equal to 0 only we get. So comparing real part, 0 can be written as 0 plus I into 0. So that's why when you compare the real and imaginary parts here, we get cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 0. It can be written as 2 cos square alpha minus 1 plus this is 2 cos square beta minus 1 plus 2 cos square gamma minus 1. So we have is equal to 0. We have here cos 2 theta is equal to 2 cos square theta minus 1. As per this we can write like this. So then here 2 cos square alpha, 2 cos square beta and 2 cos square gamma. If you take 2 common, so then cos square alpha plus cos square beta plus cos square gamma and minus 1 which becomes minus 3, so which is equal to 0. So finally we can write from this cos square alpha plus cos square beta plus cos square gamma, which is equal to 3 by 2. See, we get here cos square alpha plus cos square beta plus cos square gamma is equal to 3 by 2. Again we have to prove that sin square alpha plus sin square beta plus sin square gamma, which is also is equal to 3 by 2. We have to prove that 3 by 2. So for that purpose here cos square alpha we can write 1 minus sin square alpha from the identity. This is 1 minus sin square beta and here 1 minus sin square gamma, which is equal to also 3 by 2. So from this here, so 1 plus 1 plus 1 is 3, and from these 3 terms if you take minus common, so sin square alpha plus sin square beta plus sin square gamma, so which is equal to 3 by 2. So then from this if you send the sin square alpha plus sin square beta plus sin square gamma here in the right hand side, then bring the 3 by 2 to the left side, so 3 minus 3 by 2, so which is equal to sin square alpha plus sin square beta plus sin square gamma we get. So from this here 3 minus 3 by 2 is equal to 3 by 2 only. So that's why 3 by 2 is equal to sin square alpha plus sin square beta plus sin square gamma. So like this we can prove that cos square alpha plus cos square beta plus cos square gamma is also is equal to 3 by 2, and from this we can prove that so sin square alpha plus sin square beta plus sin square gamma is also is equal to 3 by 2. Like this we can prove.